Hello everyone, welcome to ULCA. ULCA, which stands for Universal Language Contribution API, developed by METI, is a standard API and open scalable data platform for datasets, models, and benchmarking for the Indian languages. This is part of the broader NLTM initiative or Bharshini. ULCA will help researchers develop language AI technologies including machine translation or NMT, automatic speech recognition or ASR, text-to-speech or TTS, and optical character recognition or OCR in all the 22 Indian languages. ULCA aims to become the premier repository for the Indian language resources. All the APIs used in ULCA are documented as open APIs using Swagger. There are three main components of ULCA, namely datasets, models, and benchmarking. To train AI models, large amounts of data are required. ULCA has a collection of such large datasets that have been collected over a period of time. ULCA supports summation of the following types of datasets: parallel corpus, which are the parallel sentences in two different languages with the same meaning; ASR datasets, which are audio to text mapping; TTS datasets, which are similar to ASR but usually the audio is recorded in a studio for best quality; ASR unlabeled datasets, which are audio file snippets without the transcripts. OCR datasets are basically image to text mapping. ULCA will expand to other dataset types such as POS, NER, NLU, and NLG datasets. The datasets contain records belonging to various domains such as news, education, finance, healthcare, sports, and many more. These records are collected through various methods such as machine translation with post-editing, auto-aligned algorithm, crowdsourcing, etc. The dataset also maintains other metadata which should be discussed in subsequent videos. ULCA also contains a repository of language AI models in Indian languages. These models have typically been trained using the datasets we talked about earlier. A trained language AI model performs some specific tasks such as machine translation, which means automatic translation of text from one Indian language to another; automatic speech recognition, meaning automatic transcription of audio data in Indian languages; optical character recognition, meaning automatic detection of text in Indian languages from images; text-to-speech, wherein text is converted into natural sounding speech. Already, 92 models in machine translation, ASR, OCR, and TTS have been submitted. Over time, it is expected that researchers will submit better tuned models for various language AI tasks. Let us demonstrate how some of these models work. Let's start with translation. Let's say we pick up the language pair as English Hindi. Here we can see that 5 teams have submitted their respective model for this language pair. Let's click on one of them. Here we can get a detailed view about this model. It also contains the benchmarking scores against a particular benchmark dataset and metric. We will cover more regarding the benchmarking process in a while. For now, let's go ahead and try out this model. I'm pasting a sample sentence and clicking on Translate to get the translated output which the model had returned to ULCA. Let's quickly try a couple of other language pairs. Let's try one more. What we are seeing here is that once an inference is initiated, ULCA makes a call to the endpoint where the model is hosted and displays the inferred sentence as output. Let us now look at the ASR models. ULCA provides two options to infer ASR models. One is the live inference, wherein the audio gets transcribed as we speak. The other is the batch inference, where we can upload an audio file and get the respective transcription. We will try both of the types now. For live inference, let's select a Hindi model. Let's click on Try Me, and we can click on the record button and it can start to infer as we speak.
इसको हम इस प्रकार से समझें कि जैसे मानव शरीर एक है, किंतु उसके प्रत्येक अंग प्रत्यंग का अपना एक कार्य है और उस संपूर्णता में उसका अपना योगदान है। यदि कोई एक अंग कार्य नहीं करता है ठीक से, तो उसका प्रभाव केवल उस अंग तक सीमित नहीं रहता है।
So here there's an option to play back the recording as well, and in the output we saw that it was inferring as we were speaking. Now let's try a couple of other languages as well. Let's try maybe Sanskrit this time.
एवं विधं सुखं कुतः लभ्यते इति वयं न जानीमः। सामान्यतः वयं चिन्तयामः सुखम् अर्थात् अनुकूलं संवेदनं, दुःखम् अर्थात् प्रतिकूलं संवेदनं। Now let's try one more from Tamil.
வருகிற 2ஆம் தேதி புதன்கிழமை காலை 8 மணி முதல் 5ஆம் தேதி மாலை 5 மணி வரை இடங்களை தேர்வு செய்து கொள்ளலாம். மருத்துவ கலந்தாய்வில் பங்கேற்கும் மாணவர்கள் வருகிற 7ஆம் தேதி சான்றிதழ்கள் சரிபார்ப்பிற்கு அழைக்கப்படுவார்கள் என அறிவிப்பு.
For the batch inference, it's relatively straightforward. So we can select a model and we have to provide a publicly accessible URL here of the audio file, and we can get the corresponding transcript. Let us now look at the TTS models. As we discussed earlier, these models are used to generate natural sounding speech for an input text. Let's quickly try a couple of models. A TTS model accepts an input text and a gender selection for the output voice. I'm pasting an input sentence, and let's first try with a female voice and do a convert. Let's try playing the output.
இம்மாவட்டத்தின் மேற்கில் கேரள மாநிலத்தின் திருவனந்தபுரம் மாவட்டமும் வடக்கு மற்றும் கிழக்கிலும் திருநெல்வேலி மாவட்டமும் எல்லைகளாக உள்ளன.
Let's now try with a male voice.
இம்மாவட்டத்தின் மேற்கில் கேரள மாநிலத்தின் திருவனந்தபுரம் மாவட்டமும் வடக்கு மற்றும் கிழக்கிலும் திருநெல்வேலி மாவட்டமும் எல்லைகளாக உள்ளன.
That's pretty good. We'll try one more model. I already have a sample sentence. Copy paste. This is for Hindi.
शिवाजी महाराज के चरित्र पर माता पिता का बहुत प्रभाव पड़ा। उनका बचपन उनकी माता के मार्गदर्शन में बीता।
Let's quickly try a mail.
शिवाजी महाराज के चरित्र पर माता पिता का बहुत प्रभाव पड़ा। उनका बचपन उनकी माता के मार्गदर्शन में बीता।
Now let's try out some OCR models. As we already discussed, OCR model helps in extracting the text from images. We see a few OCR models, and let's try a couple of them. Maybe we can pick up Kannada and do a try model. ULCA supports OCR inference in a couple of ways. as a first option, we can infer by feeding an image from the local drive. As a second option, we can infer by providing a publicly accessible URL of the image. Let's go ahead and try option 1 for Kannada and do a convert. So here we can see the inferred text for Kannada. Let's go and try a second option with a different language, say Malayalam, and I'm clicking on try model, and I've already saved a URL, so let me copy and paste it and do a convert. As we can see, the image that we are trying to infer is also shown for reference. Along with this, we see the extracted text as well. Benchmarking is a key part of the ULCA platform to measure the performance of the language AI models. In other words, the effectiveness or efficiency of a model is defined as benchmarking, which is usually done against a standard golden dataset with an universally accepted metrics for the given task type. A benchmark dataset is a collection of carefully human-curated records which act as a golden dataset. Having the right benchmarks and metrics are critical for the progress of the language AI models. There are some popular benchmarking datasets for the Indian languages across various task types. For translation, the popular ones are Flores, which is from Facebook, WMT and WAT, which are released as part of the notable competitions, and TICO, which is a healthcare related benchmark dataset. Similarly, for ASR, we have MUCS and MSR. There are some universally accepted metrics for the models based on the task type. For example, Blue, Meteor, RIPES, Glue, and BERT are some of the popular metrics for the translation models. Similarly, WER and CER are popular among the ASR and OCR models. The ULCA GitHub page talks in detail about the libraries or implementation details for each of these metrics. In ULCA, we are adding the support for all the possible benchmark datasets and metrics as we speak. We can view all the existing benchmarking dataset by selecting Model and then Benchmark Datasets. We have a grouping view by the task type. The card gives the high-level information, clicking on which takes us to the detailed view. This also contains the leaderboard, where the models are ranked based on their respective scores against the selected metric during the benchmark process. In simple words, the leaderboard gives us top performing models for the given benchmark dataset and metric. We will cover detailed information on how you can contribute to ULCA in further videos.